Hello and welcome to Module 3, Creating Virtual Machines. This is the third module in 12, Creating Virtual Machines, where we will cover just what it says, creating a new virtual machine. The importance of this module. You can create a virtual machine in several ways. Choosing the correct method can help you save time and make the deployment process manageable and scalable. The module lessons. Lesson 1, Virtual Machine Concepts. Lesson 2, Creating a Virtual Machine. The learner objectives for this module. By the end of this lesson, you should be able to meet the following objectives. Identify the files that make up a virtual machine. Compare virtual machine hardware version 11 to other versions. Describe the components of a virtual machine. Compare and contrast the types of virtual disk provisioning. View the console of a virtual machine. About virtual machine files. VM files are stored in the directory in the data store. That virtual machine is actually consisting of a set of related files. The VM folder usually contains all the VM files, but this depends on how the VM is built. The .vmx file, this is the VM's configuration file, which includes device settings. The .vmtx, this is the template file, and it can create a VM and convert to a template. It can't be powered on, but is used for deployment. To use, you copy the template or clone it to a live virtual machine. This replaces the .vmx when a virtual machine is converted to a template file. The .vmdk file. This is the HDD file or hard disk file. It can be a disk descriptor or the actual data. The info is stored here. If the operating system doesn't recognize SCSI, it can also see it as an IDE disk. There's usually more than one .vmdk file. The rdm.vdk file. This is a raw device map, and it's used for the virtual machine when it requires disk storage in a raw device type. The vmsd and vmsn files. These are snapshot files for restoring the virtual machine to previously saved state. We also have the delta.vdmk file. Excuse me, that's a vmdk file. These are delta files store changes to the disk since the current or last snapshot. So you can delete or ignore these deltas. In our NetLab environment, when it spins up, it creates a delta vmdk file. But as it's a normalized lab, it restarts from the original vmdk and ignores the deltas. And we have the .log files. These log files, up to 6 of these can be maintained at once, and the oldest log file will be rotated out as needed. A virtual machine uses virtual hardware. It appears as real hardware to virtual machines. The uniform hardware makes virtual machines portable across hosts. It has the ability to support up to 128 virtual CPUs, up to 4 terabytes of RAM, also supports hardware 3D, up to 10 virtual NICs, 2 IDE controller devices, up to 3 parallel ports, 32 serial COM ports, a VMCI controller, an AHCI controller, a USB controller with up to 20 devices, has a single floppy controller for up to 2 devices, up to 4 SCSI adapters, and each of those SCSI adapters can handle 15 devices. It also has mouse and keyboard. A couple of notes. The USB device attaches to a single virtual machine and cannot be shared amongst the virtual machines nor the hosts. The virtual ports are passed through to the ESXi hosts. If you want a serial port in the virtual machine, you can extend it into the physical host serial port. The VMCI controller is the virtual machine communication interface. It provides communication between a virtual machine and the ESXi host operating system. It reduces your network overhead by bypassing the network layer entirely. You can get up to 10 gigabits per second. The VMX Net 3 only gets 2 gigabits per second. And it can be both connectionless and connection-oriented. Next, let's take a look at the virtual hardware versions. Each release of a VMware product has a corresponding virtual machine hardware version included. This is the hardware abstraction layer, or HAL. It's based on the hypervisor in use, the hardware version number, or HAL changes. If you create a virtual machine in OVA/OVF on 6, you can't open it on ESXi 5.5, which is version 10, but it is backward compatible. About virtual hardware version 11. Now, virtual hardware version 11 has several features and benefits. Some of the new features that come with hardware 11: VMX Net 3. This is a high performance interface. You get up to 2 gigabits per second. Also, vNUMA aware hot add RAM, WDDM 1.1 GDI acceleration, and extended support for virtual graphics, including NVIDIA vGPUs. You also get expanded guest operating system support for Solaris 11.2, Oracle Unbreakable Enterprise Kernel Release 3, Quarterly Update 3, ASUNEX 4 SP4, Ubuntu 12.04.5 and 14.04.1, Oracle Linux 7, FreeBSD 9.3, Mac OS 10.10. The VMware tools add on to the virtual machines for better mouse and keyboard support, remote shutdown of virtual machines using Icon in the sphere, vSphere. This is passed to the operating system, and on Linux you can log in as sudo pass command shutdown -H0. About CPU and memory. You can add, change, or configure your CPU and memory resources to improve your virtual machine performance. Notice that you have a maximum number of virtual CPUs that you can assign to a virtual machine, and that will be dependent upon the number of logical CPUs on the host, and the host licenses, and the type of installed guest operating system. A virtual machine cannot have more virtual CPUs than the logical number of logical CPUs on the host. You set the parameters when you create, or you can do it afterwards. Some can be hot added, others require the virtual machine to be shut down. And you can accept the default unlimited memory resources. The ESXi host limits the memory resource use to the maximum useful for the virtual machine. About virtual disks. A virtual machine usually has at least one virtual disk. Adding the first virtual disk implicitly adds a virtual SCSI adapter to complete the connection. So you have at minimum one virtual disk per virtual machine. The .vmdk file is stored in the data store. Remember that this is the .vmdk file that actually holds the data. The .vmdk file is a disk descriptor file. It assigns the disk size, place in data store, or the place in the data store where these reside, and then what kind. Is it SCSI, SAS, etc. It also has the disk mode, whether it's persistent or non-persistent, and if snapshotting is included. Also displays the provision policy, whether it's thick or thin provisioned. The -flat.vmdk file is the one that actually holds the data. So I misspoke earlier. The .vmdk file is a disk descriptor file. The -flat.vmdk file holds the actual data. And there may be more than one of these flat files if the disk is split. You can see in the example here that under virtual disk files that server1 .vmdk and server1-flat.vmdk are the names of the two virtual disk files. You can also see next to default disk mode that the snapshots are allowed. One of the things that you'll have to decide is how you will provision your virtual disk, whether you'll use thick or thin provisioning. Now, thick provisioning uses all the defined space at the creation of the virtual disk. The virtual machine disks consume all the capacity as defined at creation, regardless of the amount of data in the guest operating system file system. There's two ways to do this. You have eager zeroed or lazy zeroed. Every block in an eager zeroed thick provision disk is pre-filled with a 0. Every block in a lazy zero thick provision disk is filled with a 0 when data is written to the block. So let's say that you have 10 gigabytes of actual physical disk space and you thick provision an 8 gigabyte virtual disk on the virtual machine. Only 2 gigabytes will be available for use by other virtual machines. That's because you reserved or set aside 8 gigabytes of those 10 gigabytes. It's not recommended to use thick because although the virtual machine may grab those 8 gigabytes when its operating system is installed, it may actually require it. However, upon loading it may only need 2 gigabytes. Therefore, the extra 6 gigabytes that were allocated to the virtual machine when you created it will be unused and wasted. So the difference between eager zero and lazy zero is really whether you're pre-filling that disk with zeros or you're filling that disk on demand. So with both types, the space is set aside. This is thick provisioned. However, with lazy zeroed, each block on the disk is only filled with a 0 at the time the disk is written to the block. Now, the downside is this can cause some I/O latency due to the zero write activity on a busy disk, such as an Exchange database server. Every time you're writing to the Exchange database server, you're going to have to write zeros. However, a web server is pretty static, so this would work pretty well there. You're not writing too much to a web server. You could use the eager zero for servers that have a lot of write activity, such as an Exchange server. Therefore, you pre-fill with the zeros, and now you don't have that latency. Another solution is to use thin provision virtual disks. Thin provisioning enables the virtual machines to use storage space as needed. Virtual machine disks consume only the capacity needed to hold the current files. A virtual machine sees the full allocated disk size at all times. Now you can mix both thick and thin formats. You'll get full reporting and alerts that help you manage the allocations and capacity. It does provide more efficient use of storage. So let's say you have virtual disk allocation of 140 gigabytes. Your available data store capacity is 100 gigabytes, and used storage capacity is actually 80 gigabytes. Let's take a little closer look at this. So if you have that available physical storage space of 100 gigabytes, and you provision 3 virtual machines, one for 20 gigabytes, another for 40 gigabytes, and another 80 gigabytes, you provision 140 gigabytes. Now, with thin provisioning, the used capacity might be far less. Let's say your used capacity is actually only 80 gigabytes because you've only used 20 gigabytes for one virtual machine, 20 on another virtual machine, and 40 on the third virtual machine. So You may have over provisioned by 40 gigabytes. That's 140 provisioned minus 100 gigabyte actual physical space. However, there is no issue because you're only using about 80 out of 100 gigabytes of physical space. So remember, thin provision only grabs what it needs up to what you provision. You use less than what is provisioned. Some other notes about provisioning. You could use what's called thin and thick, which is when you provision your LUNs from a storage array, then you thick provision for the data store. Your virtual machines then are thin provisioned against that data store. If you use thin, then if you over provision and the virtual machines grow to their max capacity, they will have outgrown available space in the data store. The result is your disk storage collapses as a result of overwriting, causing your virtual machines to have corrupt data stores due to overwriting. Here's a Windows example. So if your log files fill up and exhaust available disk space on the boot drive, then it's going to crash the system. You'll get a blue screen. You should have been managing the log file growth, meaning that you should be pruning your log files or rolling them out or rotating them out to a more permanent storage. So, if your aggregate virtual machine size grows greater than the actual space on your storage array that data store is on, then the virtual machine operating system will not know this, but it will get a write error, and an alert will show up in your virtual machine log. You can use an example to test this. You could build a thick virtual machine drive only a couple hundred megabytes larger than what the operating system actually needs, and then do something that uses it up. Then watch your logs. The NetLab, by the way, uses OpenFiler for the software-based storage device, so you can do this with that. So provisioning compared. So let's take a look. You have thick provisioned, lazy zeroed, thick provisioned, eager zeroed, and thin provisioning. You'll also notice that we're comparing the creation time, and the fastest creation time will be within provisioning. So let's talk about each of these in turn. With thick provisioning, it is the fastest to create and uses the least amount of space initially, but the data allocation may be fragmented, which could slow down your I/O. With thick provision lazy zeroed, it's also fast, and the data is likely to be written to contiguous blocks on the data store. So that's an advantage there. But it does use more space initially than thin and may cause some I/O write delay as the blocks are zeroed out during each write. Lastly, we have thick provisioned eager zeroed. This is the slowest to create, but it has a higher chance of contiguous data and no additional I/O write delay. Let's talk about virtual networks. You can see a diagram here that we're looking at the VMware vSphere implementation on an ESXi server. Now, a virtual network is a network of virtual machines running on a physical machine. The virtual machines are logically connected so that they can send and receive data with each other. When you configure networking for a virtual machine, you select or change the network adapter type, the network connection, and whether to connect to the network when the virtual machine powers on. You can see here that we have 4 virtual machines at the top, and each one is connected to the vSphere standard switch through their vNICs. And it looks like we have 2 port groups. We'll have more about that later. And each virtual machine is connected to one of the port groups. That vSphere standard switch is then connected to the physical Ethernet adapters on the physical host. Some more about network virtual machine configuration. Some of the ESXi networking features. They provide communication between virtual machines on the same host, between virtual machines on different hosts, and between virtual and physical machines. This also enables management of your ESXi hosts. and it enables communication between VM kernel services, network file system, iSCSI, or VMware vSphere vMotion, and the physical network itself. When you configure networking for a virtual machine, you select or change a network adapter type, a network connection, and whether to connect to the network when the virtual machine powers on. About network adapters. When you configure a virtual machine, you can add network adapters or NICs and specify the adapter type. Whenever possible, you want to select VMNIC or VMXNet3. You have several supported network adapter types. There's the flexible, E1000, E1000E, VMXNet, VMXNet2, and VMXNet3, and SR-IOV pass-through. Now the VNIC is an abstraction of the actual host NIC. The two closest, the ones that actually are based on the Intel software NICs, are the E1000 and E1000E. However, the preferred type is VMXNet3. This is a virtualized adapter that has no physical counterpart. However, to use this, you must have VMware tools installed, and because this provides a driver from VMware. Also, it must be version 7 or higher. Another type is the SR-IOV, which is a pass-through that bypasses the VM kernel entirely. The VM guest is able to exchange data directly with the host's physical NIC, bypassing the virtual switch and reducing your network overhead. This is available for RHEL 6 and later, and Windows Server 2008 R2 and later. About miscellaneous devices. A virtual machine must have a virtual CPU and virtual memory. The addition of other virtual devices makes the virtual machine more useful. Data from the guest virtual kernel hardware is passed through to the host physical hardware by the VM kernel. So other devices that you might want to have specifically are the generic SCSI devices for connecting your hard disks and virtual NICs for networking. You also have representations for CD, DVD drives where you can connect physical CDs and DVDs from the host system or an ISO image. Also, you have the ability to connect USB 3.0 cards, smart card readers, and a floppy drive as well. The virtual machine console. Now, the virtual machine console provides the mouse, keyboard, and screen features to control the virtual machine. So you can open the virtual machine console from both the vSphere client and the vSphere web client. The web client requires a plugin to open the console, however. Typically, you use the console to access virtual machines, BIOS, to access the virtual machine's BIOS, to install the operating system on a virtual machine, to power cycle the virtual machine, to reset the virtual machine, and to troubleshoot the virtual machine network issues. If you actually want to log into the operating system on the virtual machine, then you're going to use something like remote desktop, virtual network connection, secure shell, PowerShell, etc.